Hello and welcome back to our series. Please subscribe to support our channel, and in this episode we're going to finish this model aeroplane and get it ready, prepped for flight. Now the bit that I really enjoy is adding the final scale details that really bring a model to life, and we have some of those for you too in this episode. It's going to be fun.
So supplied with a kit are these two vacuum forms, which are meant to fill the cowls and represent the Pratt & Whitney Twin Wasps. I think we could paint them up to look alright, but I think we could do a bit better. In fact, a while back I drew this Saito cylinder, and we're going to use this to create our own dummy engines. Now over to the 3D printer. We use a heated bed for printing and Pritt stick glue for additional adhesion. A raft also helps the part stick down to the build platform, and this is a time lapse as the process took a couple of hours for each part. Each engine is made up of 2 rings and 6 brackets. Making them in parts reduces the need for support material and hence waste. It also makes cleanup easier before assembly. Cyanoacrylate CA glue works great on these PLA plastic parts, and the inner ring component is designed to clear the motor can by 1 mm all the way round.
Now to the spray booth in the garden.
So we will put down this silver base coat with a rattle can, and the trick here is to build the colour up gradually in many thin coats. Now when they're completely dry, we're going to make up a dark paint wash. We're going to make it from these small tins of Humroll paint, 1 part paint to 5 parts white spirit. This will just bring out the raised detail of the fins on the cylinders. The effect is only subtle, but when compared against the one that has not been done yet, it's quite pronounced. I find that these little enamel tinlets tend to settle out, especially the metallics, so here I'm using a cocktail stick to stir it back up. We're using this brass colour just to pick out some details, such as the cylinder push rods. Now this very thin down paint takes ages to dry. However, when it is, we can fit the dummy engines, so here I'm using CA glue and small pieces of card to ensure correct clearance. Here I've applied pieces of masking tape and then measured a set distance to the centre of each cowl retention block. By setting our compasses, dividers or calipers to that distance, we can mark precisely where to drill the holes. The cowlings are moulded woven fiberglass made with epoxy resin, and we must open these holes out with a bigger drill to prevent them from splitting. On this real DC-3 we can also see some prominent features that we are also going to 3D print and add to our cowlings. First there is the oil cooler at the bottom of the cowling and the exhaust pipes down the sides. Because the 3D printed layers go along these round parts rather than across them, they are quite noticeable. So here we are using acrylic stopper putty, and when dry we'll sand it smooth before painting. Once the silver base coat has completely dried, here I am applying some shades of brown and orange using a sponge. Just a light pass with some heavily thinned matte black with the airbrush completes the effect before the exhaust pipes are fixed in place. Once the oil coolers were added, I applied some streaks of dirt here and there with the airbrush. It's important to clean the airbrush straight away, but this ultrasonic jewellery cleaner makes short work of the task. Now there are one or two decals to apply, and these are printed on a clear background, so just take your time and they look quite smart when finished. I made a former from some scrap wood, and here we are using a paint stripping gun and some clear plastic packaging to make the light covers. Once marked and cut out, these are fixed into position using Yoo-Hoo-Pour. Don't be tempted to use CA glue for this task, as it will fog the clear parts. I then framed the edges of these light covers using strips of the self-adhesive silver covering material supplied in the spare swatch with the kit. And talking of stickers, now is a good time to fit our CAA operator's ID. Most important, now it's time to check the correct control throws. Do each surface in turn, setting the travel as per the instructions. Here the aileron differential is quite apparent. I also set a small amount of exponential to soften the elevator. This is where I had to place the flight battery to achieve the correct centre of gravity.
Welcome to our field. You'll see it's not really suitable for flying at the moment, but it's perfectly good enough for the two checks that we're going to do today. First is a range check, and then we're going to check the failsafe.
Notice we haven't fitted the propellers yet for this exercise.
So first we need to put the transmitter into range check mode, and then with this system we need to pace out 30 metres.
Then we shall check the radio link by moving the control surfaces and noting the number of fades and holds. Then we'll turn the model round a bit and repeat.
So you'll notice there's a control input at the moment, and we're going to check the failsafe. So I'm going to ask my expert helper, Gwen, to switch off the transmitter. There we go, we can see we've entered failsafe mode. The control surfaces have all gone to neutral and the gear has retracted, which is how we set it. Brilliant, it works.
And now finally she's all finished. In total the build took around 15 hours. All that weight turned out to be 8 pounds dead on, so 400 watts per motor sounds just about perfect. I can't wait till next time where we'll conduct the maiden flight. Please subscribe to support our channel, and we'll see you next time.